Cross your fingers. Connecting live video on Facebook. And it looks like we're up on Facebook. I think it. Let's see.
I think it.
I think it. Looks like we're up on YouTube too. I think it.
I think it.
Check the audio mixer. All looks good. We're good on OBS. Just another moment that I be sure that everything's fine. There. Oh, hey. Oh, hey, we're live. Hey, good evening. Oh, let's go live on Facebook. Just didn't hit the go live button.
I was going to say, don't say yet. Yeah. Hey, welcome to my nightmare.
Welcome. Alex Cooper.
I think we're up on YouTube now for 51 seconds.
All right.
Our privacy is okay. Our stream is public, and we're up on Facebook. There. How we doing now, guys? Anybody watching the stream? All right. Nobody's watching? Perfect. I guess that part's up to me. Well, okay. So anyway, good evening, everybody, and welcome back to our Sunday night offering of Astronomy Outreach, the Sunday Night Astronomy Show. Maybe you guys can check on YouTube and Facebook there to be sure that we're looking okay on your end. I'm seeing from the publisher end here, looks like it's okay.
Facebook looks good.
Facebook looks good. How's YouTube looking? Probably good too.
I don't have that.
Well, we'll just assume it is.
Yeah.
There's Denise on Facebook. Welcome, Denise.
Hey, Denise.
And we're in. Okay, so good evening, everybody, and welcome back to our Sunday night offering of Astronomy Outreach, the Sunday Night Astronomy Show. First of all, I'd like to welcome back Mr. Paul Owen. Hey, I don't have to pin you now. I can just look at that. You can just wave. All of us can wave at the same time. And Mr. Mike Powell's back with us from the PFO Observatory here in St. John. Hey, Mike.
Hey.
Good evening.
Hey.
And folks, we're trying a couple of new things tonight. Number one, we're streaming out at 30 frames per second, which is a little bit better signal. I think we've all set our cameras to 720p at least, so we're working on getting ahead to the 1080p format, which we're hoping that will come pretty soon. But at the moment, we're just taking it one step at a time, and we're working ahead. So tonight we're joining you through a Google Meets call, and that's probably the way we're going to continue with our presentations in the near future, at least. Google Hangouts is kind of disappearing a bit, and this seems to work out for a better format for all of us. We've been experimenting a little bit through the past week just to see how things are going along. So I don't see anything on the live chat yet through YouTube, but we'll just wait for that. I think it's all enabled.
I got the YouTube stream up. It looks good.
Okay, good. So tonight we're going to start off with a brief talk again about what's up in space this week, and then Mike's going to provide us with some information on the different types of eyepiece filters to choose, and how to choose one that'll work best for you when you're trying to bring out the most detail in the object that you're viewing. And then we'll take a brief break to announce the winner of the Snap contest that I had offered last night when I had asked people to go out and capture a photo of the conjunction of the Moon and Mars and send it in. So that happened. I got about 44 entries. 44 entries, like in an hour. It was nuts.
Wow.
Yeah, so awesome participation. And I hope everybody really enjoyed the view. I know I enjoyed it. I got a chance to go out and look at it. I think, Paul, we finished our call around 2:30 or so I quickly went outside and took a quick look, and we could see that the Moon and Mars were very close together at that time. Mike, get up.
It was amazing.
Oh, it was really nice. Building up to that big event that's coming up on December the 21st, of course, which is the Great Conjunction. Paul's going to offer his part 2 of his mini workshop just after the contest draw that he's calling the Beginner's Astrophotography with just a DSLR, where he'll be continuing the discussion on the basics for getting a great moon picture. And then we're going to pause again to introduce your wonderful photo submissions for the week. And finally, if there is time, a quick look at what's to watch for in the night sky over the next week or so. So another pretty full show on the way, everybody. So sit back and enjoy. And remember, this is a live broadcast. So if you have questions about the night sky, we're happy to try and answer them here for you. So I guess we'll get started with what's up in space this week. And I guess that's up to me, isn't it? That's my part. Lots of notes. Great. Let's take a look here, see what I can find. See how much trouble I can get into.
They're making some noise back there.
Me?
Yes.
I'm making noise?
No.
Oh, they're making
They're making.
behind you. So people take a look at what Mike has in his background there. Something that changes every week. We are going to run a contest on that pretty soon. We'll offer a nice prize for what's changed in Mike's background every week through the show. Anyway, what's new in space this week? Don't know if you guys can't see that yet, but I got to share my screen, I guess, first of all, don't I? Probably best. Present now. The screen.
Mm-hmm.
You got an asteroid coming by?
Well, there. How's that one?
There.
Yeah, I can see it. Okay. Well, actually, a satellite over half a century old finally burned up in space. On August the 29th, a NASA satellite that launched in September 1964 burned up in Earth's atmosphere. The long-retired spacecraft weighed 487 kilograms, and it was the first. It was the first in a series of 5 missions designed to observe the magnetic environment around Earth. NASA officials said the satellite, called the Orbiting Geophysics Observatory 1, or OGO-1, posed no threat to humans when it burned up. That's a good thing. That's always a good thing. Next up, scientists map Andromeda's galactic halo, and it's bigger than expected. Galactic halos are both massive and more complicated than scientists realized, according to new observations from the Hubble Space Telescope. The venerable telescope turns its sights on the neighboring Andromeda galaxy using dozens of different quasars to map the galactic halo. Andromeda, more formally known as M31, is a spiral-shaped galaxy about the same size of the Milky Way we live in, with about 1 trillion stars. 1 trillion stars.
Wow.
Wow. Cosmically, it's right next door, just 2.5 million light years away, just down the street, which means that Hubble can study its halo in unprecedented detail. The Andromeda Galaxy's halo isn't just a convenient target. Scientists also think that given other similarities between our neighbor and our own galaxy, Andromeda's halo may teach us about the Milky Way's own halo, which is difficult to study from within the galaxy. The researchers found that the halo itself stretched much farther across space than they had expected, out to a whopping 1.3 million light years out from the galaxy, and at some spots more like 2 million light years. Well, if the human eyes could see it, it would be 3 times as wide as the Big Dipper, according to NASA.
Wow.
Wow. In starker terms, Andromeda's halo covers more than half the distance between Andromeda and the Milky Way, suggesting actually that the 2 halos might even intermingle. So if you could see Andromeda in the sky, if we could see Andromeda like this in the sky, if our sky was always this dark, it would appear 6 times larger than the full moon, from 2.5 million light years away. So that's the massive size of the galaxy.
3 degrees wide, I guess. Yeah.
Yeah.
Wouldn't it be cool to be able to capture that?
Wouldn't it? Wouldn't it be cool to be here in 4 billion years when it comes a lot closer? Oh, who knows? We might be back. Next up, NASA test fires the booster of its moon mega rocket. NASA's new moon rocket finished a full-scale flight support booster test Wednesday as the agency gets its Space Launch System, or SLS, ready to fly astronauts one day. The 2-minute test was broadcast live from Utah on NASA television, and the results will be analyzed to see how well it went, officials said during the broadcast. Footage from NASA showed the horizontal booster firing up on its test stand and shooting out orange flames against the gray, hilly landscape. The booster was supposed to fire 3.6 million pounds of thrust upon ignition and remain active for 122 seconds, but the exact performance metrics will be released at a later time. Minutes after the test concluded, steam from the flame's heat continued to rise from the landscape. Results from this test will be used to ready the builds of booster rockets after the Artemis 3 mission, NASA said in the statement. Artemis 3 is supposed to be the final human landing supposed to be the first human landing on the moon, and is scheduled to take place in 2024. But the agency is working on building out its future rocket and spacecraft now to be ready for the future missions as well. So we're on our way, maybe.
Well,
At least we can go horizontally now. We just can't
Yeah.
go vertically yet.
yeah.
And 43 years ago, on September the 5th, 1977, Voyager 1 began its epic journey through deep space with a glorious morning launch from Cape Canaveral, Florida. Voyager 1 initially launched on a mission to explore the outer planets. After flying by Jupiter and Saturn in 1979 and 1980, the spacecraft took a sharp turn and started heading straight out of the solar system. Voyager 1 became the first spacecraft to reach interstellar space in 2012, although scientists are still debating about how exactly or where exactly that boundary lies. The spacecraft's next big encounter will take place in about 40,000 years, when it will fly by another star system. And just in case it comes across any intelligent life out there in the universe, it's carrying a golden record with sights, sounds, and greetings from planet Earth. I'm going to have a bigger discussion on this amazing spacecraft coming up in a few weeks' time. And finally, tonight, which one we're going to? I had a couple of stories to go with. I had a real hard time choosing which one it was going to be, but I think we'll go with we'll save the other one for next week, and I'll go with not this one, but we'll go with this one.
Yes. Or a frisbee.
Flat Earthers end up in quarantine after sailing to the end of the world. After 2020 put a stop to a planned flat Earth cruise to Antarctica, where passengers hoped to find the giant wall of ice they believe surrounds a flat disk of a planet, one Italian couple took matters into their own hands. The man and woman, both from Venice, set sail towards Lampedusa, an island between Sicily and North Africa, to find the end of the world, which they believe is near the Sicilian island, reports Italy's La Repubblica. After having sold their car to buy a boat in Termini Imerse, a town in northern Sicily, the couple had to sail around the island to make it to Lampedusa, which in the last decade has become a common transit point for migrants and refugees trying to make the treacherous journey from Africa to Europe across the Mediterranean Sea. Unfortunately for the flat earther duo, they didn't quite make it to their intended destination, ending up instead in Ustica, an island situated just northwest of where they set off. A doctor at the Maritime Health Office of the Ministry of Health, who helped the couple after they got lost, revealed that they were using a compass to navigate. He said, presented a problem. Quote, the funny thing is that they orient themselves with the compass, an instrument that works on the basis of terrestrial magnetism, he told the Italian newspaper, a principle that they, as flat earthers, should actually reject. The couple were taken to a quarantine on Ustica before trying to escape, being taken back to quarantine, and then trying and failing to escape it once again. After they had decided to stay put and fulfill their required time in quarantine, the couple abandoned their doomed boat and took a ferry back to mainland Italy. So I guess that's where the end of the Earth is. Still trying to find that Great Wall. We're in Antarctica. I'm sure it's out there somewhere.
It's sailed off the edge already.
Maybe so. And that's what's up in space this week. So we'll save the other one for next week. That's kind of a neat one, too. It's all about lunar pee. Peeing on the moon.
Oh, okay.
Yeah.
Wow. That's what your
I'll
mind.
keep you in suspense for that one.
Yeah.
Lunar waterfalls.
Yep.
Nice.
Hold your water till next week.
If you can't, you're in trouble.
Yeah.
Hard to pee into the wind.
Yeah.
I'm peeing on.
Oh boy, here we go. Show's going down here real fast. But we'll stop it right there. And we'll get Mike to carry on probably with his conversation now on his discussion on what to look at when you're choosing planetary filters.
Okay.
Meantime, I'm going to get the rest of these contest entries ready to go, and we'll do our draw right after Mike.
Present the window, make sure I get the right window, and share. All right. We should see something up and running.
Yeah.
Yep, all good.
And click on the
Oh.
button.
We lost you there again.
Oh, am I still presenting there?
You're still presenting, but you've got a black screen.
Back screen, yeah.
Oh, really? How'd that happen? Let me try this one more time.
Okay, we had you a second ago.
Present now. Window.
You're choosing a full screen instead of a window?
No, that's what it was.
Yeah.
The entire screen. That's what I'm looking for. This one.
So before we present, just want to say hello to Trudy Sighorn, Anton Tab Jopko, first time here. Hey, welcome, Anton. Bruce Kasuji is here. Norfolk, Ontario astronomers. Awesome. Good to see you. And Alan's here. Hey. Okay, folks. And I'll say hello to the Facebook crowd as soon as we get through Mike's presentation.
So we should be up and running this time.
We are. Let me pin you, Mike, or pin your presentation so you can get everything up on the screen there. There we go.
There you go. Snaz.
Our fancy speckle. And tonight, I'm just going to do a quick talk on. Come on, I'm clicking next and it ain't moving. There we go. Planetary and color filter sets. Everybody's got one. It's those 4 filters that you get in a little round disc. When you first buy your first telescope, if you get lucky, it came with the telescope as part of the eyepiece. And it won't flip for me. Go to the next page. There we go. So a basic planetary set. Filter set consists of a red, a green, a yellow, and either a neutral density filter or a blue filter. They're not very expensive. They run anywhere from, say, 20 bucks Canadian to 25 bucks Canadian, depending on where you buy it. Or you can go the big set. If I can get it to flip again. My page isn't flipping for some reason. I'm froze. There we go. The big set by Orion. They put one out. It covers pretty much every color of the rainbow and the Ratten number, and it costs you about 199 bucks US. I'd just like to talk about the basic set of 4 and what good is it. As the name suggests, these filters sort the colors of the spectrum, blocking certain colors and allowing others to pass. They're very useful when viewing items within the solar system. Planetary surface detail and contrast has always been increased. Now they go by Ratten number, and the Ratten system is used for just ordering the different color filter types. It's named after the founder of the first photography company, British inventor Frederick Ratten, and his partner C.K. Nees. But they sold their company to Eastman Kodak in 1912. And he continued to make the filters and label them under the Ratten number. A basic 4 set is ideal for the beginner, and usually includes, like I said, a blue, a natural density or neutral density, a green, a yellow, and or a red. And you can collect others over time. I know I have. I just keep adding to the collection and adding to the collection. But the basic type is the group you want to get. I just want to quickly go through and say what some of the different colors would be good for, just as a quick example. So the number 8 or a light yellow will enhance the details on the moon surface, believe it or not. We know the moon's bright, and the yellow is not going to add to the, putting that any darker in your eyepiece, but it will bring out some contrast surfaces on the moon. It shows better contrasts for the Mars Mira, allows the red features on Jupiter's belt to stand out, and improves the resolution of Uranus or Neptune's disks. And it's effective really in larger apertures, 8-inch or above. The 11 is a green-yellow, and it darkens the Mira on Mars, so you see, you see that depth in there. Helps the surface details on Jupiter stand out. It's good for viewing the clouds of Saturn in the Cassini division, and looking at planets that are red and blue in contrast. So, a simple off color really makes a difference when you're viewing planets. The number 12 yellow, again, it makes a great lunar filter, believe it or not. It helps show the blue clouds on Mars in Mars' atmosphere, as well as lighting the planet's red and orange features. And it brings out the red and orange features of Jupiter and Saturn. So you're using the yellow filter to bring out these extra orange colors, and it's amazing that they really work. I kind of threw my filters in the corner and never bothered with them, but I started getting them out when I was looking at the planets, and they really do make a big difference. The 21 orange reduces the transmission of blue and green wavelengths. It increases the contrast between blue and green, orange and red, and yellow features. One of the best filters for viewing Mars. You're using an orange filter to view the orange planet. It's a good filter for Jupiter's belts and the Great Red Spot. It really makes that Great Red Spot stand out. A 23A is a light red. A good all-around filter that helps planets stand out against the sky. It improves the view on Mars' Mira, enhances Jupiter's belts and polar regions, and enhances Saturn's belts and polar regions. A 25 red. Again, they're starting to get a little darker. Helps planets stand out from the sky. View some of Mercury's features. Used to observe Venus's terminator. Good for Mars' Mira and sharpens the contrast on Jupiter's features. Now these are just when I went on and said, what is each filter good for? This is the suggestions that I got when I surfed the internet. The 38 dark blue. Observe Martian surface and dust storms. It's a good filter for viewing Jupiter and increases contrast of the belts and the Great Red Spot. And used for observing the rings of Saturn. Again, it really splits that Cassini division. The 47 violet, it's a darker blue. This filter blocks the green, red, and yellow wavelengths and is a good all-round filter. Is really good for viewing the moon. The best filter for observing Venus, they say. And observing the Martian polar caps. And of course, you can use it on any other planet out there like Jupiter. The 56 light green, you can view Mars polar caps and dust storms, and better contrast in Jupiter's atmosphere and the cloud belts. I would never have thought that a green filter on Jupiter would make a difference, but it really does. The 58 green blocks the blue and red wavelengths, improve contrast on Mars polar caps, enhances Saturn's polar regions and cloud belts. Moving down the list, we get to the 80A blue. It's a solid, good all-around filter. It can be used as a lunar filter, view Jupiter's cloud belts and Great Red Spot, and observes Saturn's belts and polar regions. The 82A is another good all-round filter and great for observing the moon, Mars, Jupiter, and Saturn. And they say it's a great filter for observing the brighter galaxies. It just brings out the contrast and you can see them better. These are ones that I wanted to get into, were neutral density filters. I just recently bought a new set and it came with 4. And it's basically, it gives you the first quarter, first half, 3/4, and then full moon filters. These neutral density filters transmit all colors of the wavelength uniformly. They reduce a lot of glare. They're great for viewing the moon and for splitting double stars. Now, when you're looking at the moon, like I said, I bought the 4 filter set. There's a 6, a 0.6, a 0.9, a 1.2, and a 3. And I was surprised to see the 3 because I've never seen one before. The 0.6 only allows 25% of the moon's light to come through. So it's the first quarter. That's a good filter for viewing that. It cuts out 75% of the light. A 0.09 allows 12.5%. So if you're looking at a half moon, and it cuts that light down even more, and it cuts out 87.5% of the moon's light. The 1.2 only allows 6.25% of the moon's light through, so that's great for viewing like a 3/4 moon. And then finally, the ND3 only allows 0.1% of the moon's light through, or it cuts out 99.9% of the moon's light. We're looking at a full moon. You no longer burn your retina out looking through your eyepiece when you got the full moon, when you got that 0.3 on there. And what a difference it makes when you're viewing. The neutral density filters are a great set to get your hands on. If you get the basic color set, go ahead, spend the extra $30 or $40, and that's all it is on eBay and Amazon. And SV Boney makes the great 4 moon filter set that they call it, or the natural or neutral density filters for the moon. And then finally, another little handy one that actually Paul reminded me about was the variable polarizer. It acts like a dimmer switch for your telescope. As you turn it, it gets darker. It basically polarizes the light, I guess, so it only allows certain wavelengths through, and that allows it to get darker and darker. And when you're viewing the moon, you got one filter that can do the job of four if you go with the natural density filters. And I just wanted to quickly show you some of the the planetary filters and what they're good for, what they're the different colors and that you can use to view the different planets and stuff. And here was a quick one that I saw, and I thought this was a neat slide. If you take a close look at it, you get out there and enjoy your filters, but you can see the differences in Jupiter with the red and the green and the blue. And it really brings out differences in the bands when you look, say, between the blue and the green, or the natural color of Jupiter, the RGB and the green. It really brings up those cloud structures, and it splits those bands up nicely. Same with Saturn. It really shows a good split in the Cassini division. It brings out cloud bands on the surface even better. And it takes you a while to get used to training your eyes to using these filters, because you're saying, well, I'm knocking out, everything just looks green or red or blue, but it's those different shades and the contrast of the greens and reds and blues that make all the difference in the world when you're viewing. So, most of us took that color filter set and threw them in the box in their eyepiece tray or whatever. We don't pull them out that often. But I'll tell you what, you get a whole new appreciation when you finally do get them out and start looking through them and seeing the differences that they can make in what you're looking at when you're doing planetary viewing. It's just incredible. They were out there for a reason, and now I'm starting to use them because that's what they're for, and they make a heck of a big difference. That was just a quick little talk on filters, not a big long thing. I just want to remind everybody in the end that yes, Pluto is still a planet to me. It'll always be. I'll throw that one out there because that's just the way I am.
And it is to us too, Mike. That's right.
What's that?
It is to us too. Yeah.
Yeah. Well, we're old folk, right? We're showing our age now.
That's it.
But it's like I said, I'm gaining a whole new appreciation for these planetary filters. I just looked at them once or twice when I first got them and threw them in my eyepiece box and never really thought about it again. I have pulled out a few neutral density filters to look at the moon, but I started pulling out, blue filters looking at the moon, and red and greens, and it was like, holy crap, you can see there's a whole lot of difference there when you use them.
Yeah.
And stuff that you can pick up on that you wouldn't normally pick up on not using them. It's really cool.
We do have a question here, Mike, for you. What do neutral density filters do if the scope were to be pointed on subjects on Earth during daylight? I guess it would just block out everything but that wavelength of light, right?
Yeah, I know one thing. When I take that 0.3 that knocks out all but 0.1% of the light, you can barely see through it at all. But when you look at the moon through it, it makes a big difference. I would not attempt to ever look at the sun with it, but it seems to darken out an awful lot of light. I haven't tried it on Jupiter or any of those. Neutral density filters for me have always been for the moon, and it just cuts that bright light down so you don't burn your eye out. We've all been down to the beach and watched somebody stick their eye in, their whole face lights up, and they go, "Wow!" They can't see a thing for.
Yeah, and you're looking at their eyeball, and you can see their eyeball light up, so we know that you're actually looking at it right now. Yeah.
Those neutral density filters make all the difference in the world. It softens it, and it's more pleasurable. It doesn't wreck your eye when you first look in and shock you the way it does when you're not using one.
Absolutely.
I've never tried them on terrestrial objects or anything like that, so I really, really don't know. But hey, it's worth a shot.
Dan says he's used them for solar viewing as well, with the proper solar filter, of course. Oh, that's cool, Dan. I don't think I've ever tried that.
Yeah, be interesting to do.
It would be interesting. Yeah.
I've seen people put a yellow filter on a white light. They got the white light filter on the end of their scope, and then they put a yellow filter on to give that yellowish glow on the sun filter to give it that orange look. Yeah, I've seen that, and it does. It brings out different details that you might not see.
Mm-hmm. Excellent. Thanks, Dan, for that. Kyle had one question here for guys. Maybe put it out to all of us here. Question: I find lately that the moon seems really close to you when you look at it at night. Why is that, or is there a reason?
So I guess it would be, what time of night are you looking at it? That'd be the first question.
That would be the first, yeah. Because when it's down closer to the horizon, we know that we get into that thing we call the moon illusion. where the moon looks so big at the horizon compared to when it's up above, and it's our brains that are actually playing a trick on us because it compares them to scenery that's around, trees, mountains, buildings, whatever, and it's all kind of like there's a real good demonstration when you're looking at a set of railroad tracks that are going off into a distance, and if you had a ball up at this end of the railroad tracks and the same size ball at the other end of the railroad tracks, then at this end up here front, the ball would seem a lot smaller than it does when it gets down to the very end. So it's that same kind of thing. It's our vision of infinity down there toward the end of the line, and we have other things for our brain to compare it against. But when we move the moon up into space, of course, up above our heads, there's nothing around the moon to give us any kind of perspective. So the moon appears as its normal size, which is really the sun and moon. The moon is 400 or 4,400 times, closer to us than the sun is, and it's also 400 times smaller than the sun. So the moon and the sun look the same size in the sky. Of course, that's why we can get a solar eclipse, that the moon will pass in front of the sun and we'll get the complete blockage of the sun. But that's more to do with that, I guess. So if you're down close to the horizon, you're seeing that. That's one thing. If the moon stays low on the ecliptic as well, that would mean that the moon would also appear very large for that time of year. But that's pretty well all that I could really say that would make sense of it. And if you have that doubt when you're seeing it at the horizon and you're seeing this big, huge moon, just take your fist, make a fist, and poke a hole down through the center of it, and look at the moon that way. And that'll block out everything around it, and you'll see that the moon does still appear very tiny. Take your hand away, and it appears big again. So, pretty neat trick. Or bend over, put your head between your legs, and look at the moon upside down. But I can't do that anymore. I just fall over.
Yeah. I end up like an ostrich with my head stuck in his head.
My legs are so short, I bumped my head in the ground.
So hopefully that answers your question. Who was that? It was Kyle.
Yeah, there's one other thing you can do too, is take wherever the moon is, whether it's coming up over the horizon or it's up high in the sky, take your finger, your arm extended out, and look at your pinky fingernail, and that will actually cover 2 moons. So you can do 2 moons at the tip of your finger. So if it looks big to you, say at the beginning of the night, maybe it's early, 7 o'clock and starting to come up, see if you can cover it with your pinky, which you can, and then wait for it to get up nice and high in the sky and do the same thing again. And you'll see that it's the same amount of your finger that's covering the moon. It doesn't change size. So.
Right. Absolutely. Thanks, Paul.
Yeah.
All right. So tell you what, why don't we go to the contest then next? My magic little mixing bowl. My wife loves. Yeah, she loves making a salad because then I just throw these back in the cupboard, right? So that she thinks they're all clean, but they're really not. She'll say, "Do you want some salad?" No, I'm good. Thanks very much.
I'm good.
Anyway, so what we were drawing for tonight was this Canadian Telescope's hat with a nice little beep. That's a red light. It is indeed. Look, see?
Yeah, look at that.
And what that allows you to do, of course, is put it on that way, and you can read maps and charts and things like that at night, and it doesn't take away your night vision. We all know that if we're looking at our phone, our pupils will shrink, and they'll take about 20 minutes to dilate again. So red light is the best for nighttime viewing. It has the least effect, not that it doesn't have any effect, but it has the least effect on your eyes at night when you're out observing with star charts and star maps, that type of thing. And we all use star charts and star maps outside. But anyway, if you wanted to look at anything else you're trying to find, you dropped an eyepiece on the ground, or heaven forbid, or maybe an eyepiece cap, probably more likely, or something on the ground, you're trying to find it, and you don't want to disturb your night vision, there's the best way to do it. So that hat is from Canadian Telescopes, and it has a red light on it. We're also offering this Vixen. Vixen's a pretty good name, guys, I guess, for optics.
Yeah, it's been around a long time.
Yeah, so it's a Vixen. It's called a Joyful. There you go. Joyful monocular, H7 to 21 by 21, palm-sized compact zoom monocular. So it comes in a nice little carrying bag. Inside the carrying bag is another little attachment that you can hang around your neck. Choke yourself. and here's the monocular inside the bag. So the dial is here. That allows you to dial from 7 to 21. And there's also a focus dial on it out here in front. And I tried that on the moon there last night. Pretty nice little view. Like it's 7 to 21 magnification. So and it's just a monocular, carry around with you. You going to a concert or something, you've got it for that or whatever. I'm not going to say anything else. Spying on neighbors, you know, that kind of thing. So anyway, we've got that, those surprises. And I want to say, first of all, thank you very much to Next Dome Observatories, who were the sponsor for these prizes. They're also the sponsor for our current Shoot the Moon contest, along with John Reed from Halifax, who does the 50 Things to See series of books. So these were some prizes that had been sent by Next Dome to offer out for other occasions, and that's what we're doing tonight. So let's get to the draw. I had a little over, I think it was 44 entries in an hour and a half, so pretty good for a quick hour and a half draw. And we're going to draw out the name. And now these prizes need to be picked up in St. John. I'll clarify that. So if you're not in St. John and you're in Alabama and you're watching tonight, and I can't ship them, but you can arrange for someone here to pick them up if you want for you, or you can gift them to somebody else if you'd like to do that as well. That's quite all right. So.
Or come up for a visit.
Or come up for a visit, yeah. Can't reach, Paul. Arms a little further. Here you go. Almost there. Almost. Oh, sorry. Anyway, let's go for the draw. I would let my cat do the draw here tonight, but she's taken off on me.
That's a catastrophe.
We'll carry on. Okay, and the winner is of these two nice little prizes. I didn't drop any. No, okay. Two nice little prizes is going to be Alan Burgess. Alan.
Hey, Alan.
Mine was backwards, but it's there. Alan Burgess. Congratulations, Alan. And I will be in touch on how to claim your prize and when I'm going to be around for you to be able to pick up your prize, and we will get your prize to you. Thank you so much, everybody, for participating in that contest. That's, of course, just a little snap contest. It went so well that I'm going to offer another one when another occasion pops up. But I do want to mention again that I do have a Shoot the Moon contest going on right now. Stands about 160 entries so far, which is just amazing. Wow. And we're still about 4 days away from the end of the contest. I actually have two contests, one for the moon and one for planets. Those who submitted an entry last night for the Moon and Mars competition, I'm going to enter all of those into the Moon contest part. And if you want to get a planet entry into the planet portion of the contest, just get out and take a picture of Saturn and Jupiter together over the next few nights. They're very easy to pick out in our southern sky. It's the brightest object in our southern sky right now. Just look to the left, there's Saturn. Snap a quick photo, send it in, and we'll put you into the planet portion as well. So we've got two nice contests, some really nice prizes coming up, 5 sets of binoculars to give away, 5 really nice books to give away. So we've got that draw is going to be coming up next weekend. We may even do part of it on the next week's show. So anyway, thanks so much for all the entries, and it's always fun to be able to offer something like that. Always fun to be able to offer a prize for something like that. That I didn't have to pay for. Perfect.
So just to clarify, because somebody was asking, how do you get into the giveaways? Was this one on Facebook and then done it here, or how do you do it?
This one was on Facebook, and I am trying to remember to always post up on Instagram as well, if people want to. But I did also suggest that they can send them into our Sunday Night Astronomy Show address. So I did receive a couple of entries actually through the Sunday Night Astronomy Show. So there are a few ways you can get in. You can actually comment on Facebook underneath the post that I had put up, or you can send me a private message through Facebook. You can send me a message if you're going to go from Instagram, you can send it to sundaynightastronomyshow@gmail.com. And that should cover everybody who wants to participate. And I have gone into all different areas, checked for entries today, be sure that I had everybody involved. So, and I will be doing that with the Moon contest as well. There were a number that were sent into our Sunday night address, our show, and I'll be pulling them out and putting them into an album of sorts and displaying them before the contest closes. So we'll make sure that we have everybody included. Okay. Hopefully that all makes sense. Okay, so now, Paul, I guess we're going to be over to you.
Okie dokie.
Thanks, Mike, for that excellent talk on filters, buddy.
Yeah. Yes. They say when you get older, you lose your filter. So in your case, you haven't yet.
I lost my filters long ago.
All right. So I'll see if I can get connected here and do what should be done. So bear with me for a second until I see if I can't do this. We're using a new format tonight. So entire screen. That would be this one. Click on that. And so what I'm doing tonight is a continuance from last week where we were talking about using your DSLR for some basic nighttime imaging. And I think we're kind of gearing more towards the moon. And so I'm just going to continue and finish up that segment. So it's not going to be as long as the last one. So, and I'm not going to go over what I went over last week. I'm just going to continue on with settings and so on and so forth. So let's see if we can
got the wrong screen on YouTube, Paul.
Yeah. What's that, Mike?
We got the wrong screen showing on YouTube.
Yeah.
Oh, no, I'm not showing it.
Yeah, he's not showing yet.
Oh, okay.
Yeah. So start from current slide. And you should be, I should be there now.
Okay.
There we go.
So let
You
me
see the moon?
Yep, I'm just going to pin your presentation, Paul. Second. There we go.
Okay.
We're
And I'm
good.
just going to hide that little thing down the bottom. There we go. Okay. So, so basically what we were talking about last week was we got into lenses. We got into what you're going to need in terms of the paraphernalia that you need to take out with you, like your camera, your tripod. Make sure you get lots of memory, lots of power, and keep yourself warm. Do some planning. We covered all that stuff. So this week we're going to talk a little bit about how we're going to take the picture. So what you're looking at right now is just a very, very thin crescent moon. And you'll notice that it's oriented probably the way that you would see it in the sky. But that doesn't necessarily mean that you have to take your moon picture and make it exactly this way you see it there, unless you're doing something scientific. Because there's lots of things you can do, because photography, whether it be astrophotography, for daytime photography, any kind of photography, it's all just an interpretation of what you see as an individual and what sparks you to do. You can see it in the sky. Oh, hello. So let's just have a look here. So this moon picture that I took quite a while ago, you'll notice that the moon is probably not oriented any way that we would see it. This is the way that that I thought that it showed best, because when I had it oriented the way the moon was actually sitting, it didn't show the features that I wanted to basically label as I did on this one as well. So, and I remember taking this to a presentation, and somebody who was there was more scientific oriented, and their question was, why is the moon turned like that? That's not how the moon looks in the sky. And I said, no, you're absolutely right. It's not how it looks in the sky. But when I'm looking at labeling these things, and I wanted to put the labels on, and I wanted to be able to see the features, it's just an easier look, like when you look at this in this format. So it had nothing to do with how the moon was angled, only that I want to show some features, that's all. So again, there's no right or wrong in this. It depends on what you're trying to do. So once you've decided on a suitable time or to shoot your moon, like we talked about last week, the technique's pretty straightforward. You'll need a lens of 200 millimeters or longer to get it at a reasonable size. And we talked about that, and I showed you last week the variable size moons using different sized lenses. And 200 millimeters is certainly, I would suggest probably a minimum. But again, depending on what you have, you can still get some great shots. So you're going to need to set this camera self-timer to a few seconds and set up. Okay, we'll get into that in a second. All right, so let's flip to the next one. Okay, so step 2. So once you've decided on a suitable time to shoot the moon, the technique's pretty straightforward. So you're going to need a lens of 200 millimeters or longer, and a remote shutter is certainly great to have. But if you don't have one, you can use the camera's self-timer, and I'll show you that on the next slide. So what we want to do first is, if you have a camera, whether it be Nikon camera, Canon, Sony. The important thing here is to have a manual setting on your camera, because there's not too many automatic things that the camera does well for nighttime photography. So having the camera to go to manuals is going to be the first thing that you're going to want to do. When you point your camera towards skyward as well to catch the moon, let me just put that side so you can see if I'll follow along. Whoops, where'd it go? Press the wrong button. Sorry, folks. That's locked me up. Well, now, can you see? Does that say the metering?
It says set camera to manual.
Okay, no, that's not what it is. Let me just see if I press this again.
There's metering.
Okay, set the camera to. Oh, here we go. I think I'm back. Okay. I might be. It's kind of doing its own thing.
Yeah, take some test shots. We've got it there now.
Yeah, that's not where I want to be though. Let's go back to here. And then if I click on that, whoops, click on that. Good God, no, it's kind of doing its own thing.
Yeah, mine was too.
Let me just try that again. Sorry, folks.
Okay, no problem.
Get back to there. Slideshow from current slide. And click that once. Okay, we're into metering.
Yes.
We are. Yes.
Okay, good. All right, so when you point your camera skyward to catch the moon, depending on the metering mode selected, and I'll explain what metering mode is in a second, the camera is going to think that the sky is inky black, because, again, this is where the importance of using a larger lens to get a larger moon in your camera, because the camera is going to think that take an inky black space to an account when it exposes your image. So when you're looking at the moon, the camera's looking at the moon too, but depending on, there's a little small window in your camera that actually looks at either the whole picture, it looks at part of the picture, or it center weights, it looks at the center section of the picture, and it bases its exposure based on where that is. Let me just show you that slide. Right there. So if you look at the top one, it says evaluative metering. So you can see that it covers quite an area. So if you look at that area right here, that's all gray, that means that it considers the whole frame of your picture when it's trying to adjust the exposure. The problem with that is if you take a moon that's quite small and it's a lot of black sky, then it's going to consider the black sky and the moon. It's going to say, okay, the black sky is the majority of your picture, and it's automatically going to make your moon overexposed. It's going to be a white blob of nothingness because it's trying to adapt the blackness into the lightness. So you don't want to do that. So the best thing to use for moon shots is the spot metering, because then that little spot that you see in that bottom picture is basically what would go around your moon. So it's focusing more on the light of the moon, and it's not concerned about the rest of it. So then when you base your shot and your settings on your camera, it's important to make sure that your metering is correct for the moon. So I wanted to show that one. It seems a little technical, and I didn't mean it for it to be, but this is one of the things that you'll need to know about your camera to do some of these shots. So try a few shots at various angles. Look out for lights and obstructions that may take away from your shot, and look for natural lighting that aids interest in your shots. And that just simply means if you're going out to shoot the moon and there is a foreground, whether it be a landscape, a cityscape, kind of position yourself where you can see the moon and it's kind of off to the side a little bit from the rest of it. And then if you're using your spot metering, it'll actually work its way around the moon, and then you can adjust your shot to that. And then let me just move the next one. And that's what I just said. The dynamic range. So when shooting at night, the moon may be the brightest object in the frame. So if you're including a landscape in your image, you will be considerably darker than the moon. And this will make it difficult to properly expose the moon and still retain some of the detail in the landscape. So, so many lunar photographers use composite images. And I'll show you what I mean by that. Here's one here that I did. So this particular image, and I made the moon larger than life because I wanted to show you that Obviously, this is not how big the moon would look to you here on Earth. But to make it interesting in the photograph, we can blow the moon up, make it look bigger, and do all kinds of things. But the point here was that I took two pictures. I took a picture of the scene that you see, with the parking lot and the lights going down and all that kind of stuff, getting into dusk. And actually, behind the moon is a picture of Venus, so it's just a tiny little dot of light. But what I did here was, because it was so unimpressive, a little dot of light, we might as well say it was a star. I thought I'd put a moon picture up there. So this is the part that we're talking about sometimes, you have to take two images and basically put them together in Photoshop or any kind of software that'll allow you to combine two images. We'll cover that stuff, further down the road. Something else to consider in your images is your histogram. And every camera should have a histogram. And what the histogram is that little meter that's in the back of your display. And when you look at it, you're going to see what they call a mountain range. So the mountain range just looks like a big mountain right here. And what this is designed to do is, when you look at your subject that you want to take a picture of, if this mountain range is pushed all the way to the right, you're going to be way overexposed. All the light things are going to be blown out, and you'll never be able to recover any information, and it's going to be a bad image. If it's all the way over to the left, things are going to be very dark, and then you're going to actually lose a lot of your dark detail. And again, you probably won't be able to recover it. And if you did try to recover the dark detail, by the time you got it to a point where you might be able to see it, all the other information in the middle of that picture is going to be totally washed out and absolutely full of noise. So the whole idea behind getting a clean picture without a lot of noise is to make sure that your histogram is somewhere sitting either in the first 20–30%, because most night images will actually sit there, or even a little closer to the middle if you're shooting, say, a moon over a city, because you're going to have a fair bit of light. So when you look at your histogram, when you look at your subject, make sure your histogram's turned on your camera, and try to keep that mountain range somewhere where you see it here, or maybe just a little bit before, because then you've got lots of dynamic range to play with when you're processing your pictures, and you'll be able to bring out a nice clean image. So that's the histogram. We just saw that, right? What the heck happened? Step 3. Okay, so switch your camera to the manual mode and your lens to manual focus. So on the front of your lens, you're going to have a little switch on there, and it's going to say if it's a Canon.
Paul,
yeah?
sorry, it's flipping back and forth between two slides here really quickly.
Oh, good golly. Let me just try this. There, how about there?
That's better.
Yep.
I felt like I was at a disco there for a minute.
Yeah. So switch your camera to manual mode and turn your focus to manual focus. Lots of times, depending if the moon is quite big, to be totally frank, and if all you're shooting is the moon, you can put it on autofocus, because the moon's bright enough that your focus should be able to actually pick it up and grab a good focus on it. So, but if you're doing something else where you're doing like night shots and so on, where the moon is like a very, very small sliver and it's very small in your image, you may need to go to a manual focus, because what's going to happen is if you're pressing the button to go down to get it focused and then pushing the button all the way in, each time you do that, your camera's going to want to refocus again. So you'll get one shot in, but you're going to have to refocus all over again. So if you put it on manual, it stays locked in no matter how many pictures that you take. Avoid using a slower shutter speed as you tweak the settings. This will result in the moon blurring and the image being soft. And that's simply because, depending on what you're doing, if there's clouds going by or that kind of stuff, if you're catching the moon rising and so on and so forth, the moon moves very quickly. So the faster you can use the shutter speed, then the more you're going to freeze whatever it is that you're looking at. Now we'll get into the actual settings. Maybe. There we go. So there's a rule out there called the Lunar 11. And this is where you can start setting your camera up. So what you want to do is put your camera, your camera has the f-stops. The f-stop is basically how small or big you're opening up the lens to let light in, on your lens. And so start with f11. set your set your shutter speed to 100 to start, and also set your ISO to 100 to start. And this is a really good starting point, depending on the lens and the phase. But that's a really good starting point to get your camera ready, to get something relatively clear in your camera, so that you can see it. And then you may have to tweak it a little bit here and there. So there it is there. So ISO of course is the sensitivity of the sensor. The f-stop, which is basically, how wide or small is the hole in the lens. And the shutter speed, that's self-explanatory, how fast the shutter opens and closes. So, and also shoot in RAW. And the reason I say that is because when you shoot in RAW, anything that goes on that sensor is untouched when you put it into Photoshop or Lightroom or whatever you're using to manipulate your photographs. If you're just taking a picture and just throwing on the internet and you're not doing any processing whatsoever, then go ahead and shoot JPEG, because typically that's what you're going to need to put it to anyway in order to get it on Facebook. So again, depending on what you're going to do with your photo, but if you're going to manipulate your photos and try to do some adjustments to get that moon looking crisp and clear with lots of detail, then make sure you shoot in RAW. Now, the caveat to that is that RAW takes a lot more space on your chip than what JPEG does. So just keep in mind that if you've got only one card and you've got a lot of photo stuff on it you've shot in the daytime and you're using this at night, just be conscious. Try to have a look and see how much memory you have left. Because if you shoot, say, 20, 30 shots in RAW, it chews up a lot of your memory in your memory card. So this is usually the part of okay, I've already talked about the autofocus, so we already covered that. All right, good. Focusing, this is usually the part of lunar photography that isn't challenging at all, because the moon is bright and modern autofocus systems. And I kind of just said that a moment ago, but this kind of reiterates it, and you can screenshot it if you want. But you shouldn't have any trouble locking on the moon, focusing on the moon. Depending on the scale, it may be difficult for your autofocus to lock on the moon. So the moon may not fill the frame, so judging focus can be an issue. The best way to focus is to use your live view in the back of the camera. And so if you look at your camera, you see that it's got this screen right here. And most people have that screen on the back of the camera. And you'll notice on this side, there's a plus and a minus. This is a Canon camera. And I'm not sure where it is in a Nikon. I haven't used a Nikon, but I'm sure they've got one quite handy, because these are features you use all the time. But however, so what you would do is you would get the moon in your view on your screen, and then you would hit the plus side, and that's going to make the moon blow up bigger. And because it's bigger, then you can actually see how close you are to focus. If you're still not quite where you need to be, then you can adjust your focus or try hitting autofocus again. And then you can make it bigger again. So most live views, actually in some of the newer cameras, the live views are even better, but most of the cameras that we're using for this purpose have usually 3 different angles, or 3 different size views, 3 different magnifications. The standard view on the screen, then there's the 5 times and 10 times. So use that to make sure that your image is nice and clear. And the other thing you're going to see too is if you are starting to get a little overexposed, you're going to notice on the moon that there'll be a lot of spots that are just look like white washed out little spots on the moon. If that's the case, then adjust your camera a little bit to try to bring that down, so that you're not getting any whitewash spots on the moon. So make the moon bigger for focus, and again we just covered that. So you would use 5 times then 10 times on your camera to make sure your moon is nice and crisp. Take some test shots. Try a few shots at various angles. Look out for lights or obstructions that they may take away from your shot. And again, look for natural lighting that adds interest to your shots. Try different tripod heights. And speaking of tripod heights, when you do that, if you've got a really solid tripod, that's wonderful. If you've got a tripod that's kind of shaky, I would probably try to keep your camera as low as possible to the center of gravity, so that if a little wind comes up or something, you're not going to get a lot of picture shake, which will give you blur in your image. And carry a good flashlight. It's because with a flashlight, you can be kind of creative with it. So let's say you're taking a picture of a moon over a mountain range, but obviously you're far away from the mountain range, and there's a really cool rock right in front of you. Well, while you're taking the picture of the moon in that mountain range, you can take your flashlight and actually aim it at the rock and just move it around the rock while you take your shot. That's called light painting. And then you'll have that rock lit up and in your shot along with everything else. So you have a very interesting foreground. When you're deciding when to shoot the moon, it's always worth remembering that it isn't always the same distance from the Earth. I'm going to kind of skip through this because it's not that much of a difference in size that you're going to notice between when the moon is at its closest in the year and when it's at its furthest away. It's really not that big a deal. I'm going to stack back past that. And there are some apps to help plan your shoot. So for those who didn't see the presentation last week, these are the apps that we recommend that you go out. And what these apps are designed to do is to help you find when the moon is going to be up, where it's going to be up. Is it going to be the east? Is it going to be the west? What phase of the moon is it? All of these things that you need to know rather than just going out saying, I'm going to go out and take a picture of the moon. And it may not even be up because maybe you didn't check to see that maybe it's a new moon and there isn't anything in the sky. So these things will help plan those things. Or let's say, in 2 weeks I'm going to be going away for the weekend, and I'm going away specifically and I want to take pictures of the moon. I want to see on that Saturday, on the 23rd, what's in the sky so that I can plan my shoot. So that's basically what these apps are for. So there's Stellarium, which is a free app, Skyview, which is a free app, and Sun Surveyor, which is it was at the time that I put this together, it was $10. It may be a little more now, I'm not sure. But however, it's a very, very detailed surveying app that if just go online, have a look at. It's fantastic. That is pretty much what I wanted to cover tonight, other than if there are some questions, I'd be happy to take some questions. I'm just going to start my presentation.
Okay, let's take a look here.
If you had image stabilizing on your camera, Paul, on your lens, would you leave that on or turn it off?
Okay, am I back on here now?
Yep.
Am I with you guys? Okay, good. Okay, so good question. If you're on a tripod, I recommend turning it off. And the reason that you turn it off is because it's designed so that when you're holding a camera with all the movement and shake that you have in your hands, it's designed to counter that movement and still your picture for you. When you put it on a tripod, even though the camera is extremely stable and not moving, it's still trying to do its job, sensing that things are moving. So you actually can get a blurred image from the stabilizer, trying to stabilize something that's already stabilized. So just shut that off when you're going to shoot these kind of pictures.
We do have a question from Alan Burgess is asking, can you use a stacker program with a DSLR?
Yes. Yeah, I think you can.
I did.
Yeah, is it auto stacker? Have you used that, Mike?
I used SharpCap, and I was stacking my photographs using my DSLR.
Yeah.
But I had to download that plugin for SharpCap in order to run my camera on ASCOM.
Yeah. So a DSLR, depending on what it is, if you're shooting RAW, it's going to be a CR2 format. If you're not shooting RAW, it's either going to be a TIFF or a JPEG. Most stacking softwares will handle JPEGs and TIFFs, but they may not handle CR2s. And I think there's something that you can do to get that to stack. If you can't, for some reason, then you can actually stack right in Photoshop or Lightroom. So you can stack it if you want to.
With mine, I was talking about live stacking. Sorry, not stacking.
Oh, I'm sorry.
Yeah.
Okay. Yeah. Hope that answered the question.
Yeah. Armand says I would disable image stabilization. Image stabilization, easy for you to say.
Yeah.
And Marlene says I use Star Stacks, super free, simple download, I guess. So.
Yeah. Star Stacks is great. In fact, you can use that for doing a really nice star trails. That's a very simple program. Okay. Very simple.
Awesome.
Yep.
Okay. Thanks, Paul.
Okay. Before I finish, I just want to say that I was a little shorter tonight, and I didn't have a lot of hands-on looking at the stuff. But what we're going to be doing in the future episodes is we're going to be doing how do you physically take these pictures, and we'll have some actual illustrations how to do it. And then we're going to get into how to stack, like what you guys were talking about tonight. And at the same time, we're going to get into processing. What do you do with the pictures once you got them, and how do you make them look the best that they can possibly look? So we're going to cover all of those segments.
Awesome.
Yep.
Sounds great. Yeah, looking forward to it. Lots of good talks coming up. And if Paul can't show you a good way to take a photo of the moon, he'll send you the moon. Right, Paul? We'll book a,
Oh,
we'll book a flight. We'll book a flight on the LRO. Yeah. Elon Musk will get us there. Hey. Okay, so I guess now I've been watching live stream just to be sure that we get a few drop frames here on OBS. But if anybody's having any issues, I hope we're not. I heard that there was one there that was losing sound there for a little bit, but I think we're all back again now. So again, folks, it's a bit of an experiment here tonight. With Google Meets, it may use up a little bit more memory resources than I was expecting, but hopefully you'll be able to get everything here through okay. So I guess we're going to go from here to photo submissions, if that's okay. We'll start back at that, and then from there we're going to get Paul back again to give us our Rosanna's Fun Facts episode.
Yeah, she's got an interesting one this week too. So.
All right.
Oh, they're all interesting.
Oh, they're all interesting.
They are. Every time she sends one, they just seem like this is even better than the last one. What was
Exactly.
the last one?
Even my wife looks forward to Rosanna's Fun Fact.
Yeah.
It's exciting to us.
Doesn't look laughing at us.
Because we're into, what have we got now? We're at an hour
We're
and
at
6
just
minutes. Yeah. We're into almost an hour and 15 minutes now. And so I just wanted to mention with the photo submissions, I mean, really, it's awesome that everybody's sending in photos. We're getting so many of them that what's happening is it's squeezing us in time. So we may have to, if somebody sends us in a bunch of photos, we may have to split them up over a couple of weeks to get them all squeezed in. And we just want to be sure that everybody gets an opportunity to have their photos displayed too. So I apologize if I'm not able to get to all the photos tonight. I'll get to at least some of them so I can get back to Paul's topic right after this again. But thank you very much for sending them in. Of course, they come in again to SundayNightAstronomyShow@gmail.com. That's our address. If you'd like to send them in to us, we are very happy to display them. So let's get to a few photos that we got this week from, this one's from Matthew Dupre. Let me open them up here. Oh, first of all, I got to share my screen. Boop, boop. Present now. Your entire screen. Okay. Let's go with this one. Oh, maybe we had them up there, and it looks like we had them up there anyway. Doesn't matter. We'll go again.
There you go.
Here, how's this?
Just the three of us.
There.
Oh, there you are.
Oh, wow.
Yeah, Lagoon.
Lagoon, yeah. Paul would know these ones.
Very nice.
So he says, my name is Matt Dupre. These are some of the photos I've taken over some time and would love to share them. So we'd love to get them to Matthew. Beautiful shot.
Very nice.
Gorgeous,
Let's move
yeah.
over to the moon here. Wow, what a capture.
Oh, nice shot.
Yeah, he's got some earth shot, or well, a shadow of the moon in the back on first quarter, so you can see the whole day. Very nice.
Lots of detail there, yeah.
And it's in color as well, so.
Yeah, awesome. So yeah, there is some color to the moon, isn't there?
Yeah.
Mm-hmm.
Pretty cool. Not as
Very
bland
nice.
as you think. I'd still like to go.
Yeah.
I'm learning that myself, how to shoot the moon in color.
It's awesome. Like, yeah, especially this Sea of Tranquility really does stand out.
Mm-hmm. And there's the veil.
There's the veil.
Fortune of it.
Where's
Easter.
that at, Paul?
Yeah.
That's in Leo, isn't it? Leo the Lamb?
In Leo, that's it, yeah. I don't mind Leo.
It's in Ignis.
That's the Ignis, that's the Eastern Veil?
That's the Eastern Veil.
Eastern Veil, yeah. The Western is the one with the stars.
One with the star.
Yeah,
Yeah, and then the central portion called the Pickering's Triangle.
Pickering Triangle. Awesome. Very
From
nice.
Pickering,
Man. And here's another one he's got of Orion, of course.
Oh, beautiful.
And the Running
And
Man.
the Running Man, yeah. You
Yes.
see the Running Man in there?
That's him.
That's him. That's the guy.
He's a running man.
We'll have Orion up. Actually, Orion's up now in our early morning sky.
Can I ask Matt? I don't know if Matt's watching tonight or not, but I'm
not sure.
assuming he's using, unless he put those star spikes in, is he using a Ritchie Chrétien or a
The nude?
some kind of reflecting telescope?
Yeah.
I'm not sure. I haven't seen him online yet, but he may be. Maybe
He may chime in.
he may be just hovering too and watching. So
Yeah.
yeah.
Okay.
But awesome shot there.
Very nice.
Here's one of his Milky Way shot.
Beautiful.
Very nice.
Where's the
Yeah.
first?
We've got some glow off here in the distance too.
I wonder when he shot that one. If it was recently, that would be Jupiter off to the right, the left. I mean.
That's right. Yes,
Yeah.
it would be. Yeah, it must have
It's
been.
in the right spot.
Must have been just recent. There's Sagittarius right there. So
Yeah. There's Prancing Pony.
the Prancing Pony.
Yeah.
That's that was almost as hard to pick out as a cowboy was before in double cluster, but we'll show him again some night too.
Yeah.
And I don't know what this is, Paul. Any idea?
That is part of Cygnus.
One of America.
That's all. The section that you see down by his signature. If you look just up, that spot there, that's the Great Wall
Yeah.
in NGC 7000. That's the North American Nebula.
Yeah.
Yeah, I know. I knew that. I knew you knew too. Thanks, Matt, for sending those in. Appreciate that. We've got some more to get to for Matt for next week for sure. I'm going to move on to Dave. I can't say these right. I mean, I'm just seeing these names for the first time. Dave Chirawadi, I think it is. This is from Alan Burgess, actually. He says, "Good day, sir. This is a submission for a friend of mine in Ontario. I am up here working for a couple of months. He is new to astronomy, as I am. I told him about your show and was very interested. We watched some of it last week on August 30th. His name is Dave Chirawadi. So he's got a shot here of the moon rising in Southampton, Ontario, on Lake Huron.
Oh, nice.
Nice. Yeah.
Thanks very much, Alan. You can tell your friend Dave that he is entered in our contest now too. So
Now, if that was part of his house, all he would have to do is take that top section off
and put it on.
Yeah.
Yeah.
Next dome up there, and look, you'd have the perfect observatory.
Wouldn't you?
Oh, yeah.
Never mind the lake. Just put an observatory on it. Get your priorities straight, right? Yeah. These are from Stefan Picard. Stefan says, "Hi, Chris. I'm already entered in the contest, but I thought I'd share a handful of shots from my backyard near top of Keller's Hill in Quispamsis. Jupiter." So we'll go through here a couple of moonshots that he sent us, and then he's got Jupiter and what I believe are Io and Europa, and almost a full moon, and it is a full moon that started tonight. So there's a couple of shots of Jupiter and its moons. Yeah, awesome.
Excellent.
Through a Celestron 127 power seeker,
Yes, sir.
equatorial mount. Yes, sir. An
Great.
iPhone camera, filter tools, time gazing 9:15 to 10:05. It says getting better slowly with spotting and tracking. Used to take 15 minutes to find and line up Jupiter. Was able to do it in 2 minutes now. Even found Saturn. But the clouds rolled in just before I could shoot it. So welcome to our world. Welcome to the lovely world of astronomy in the Maritimes. That just means that the better moments are much better, right, guys?
Yeah.
So
That's
no means are they very beautiful shots you usually get, but gearing up to be able to do that, just bought a Meade EXT 125 and also an SV Bony digital eyepiece.
Awesome.
I'm kind of hooked to astronomy and astrophotography now. There you go.
Awesome.
We got another guy, guys. There we go.
Yeah.
We hooked another one.
Welcome to the dots.
Hook, line, and sinker.
Exactly. And we have proof over here. Well, there.
Darth Vader is the astrophotographer, and the Star Trooper, he's just an observer, right?
That's right.
That's right. Oh, I just minimized here. I think I'm still good. Oh, what did I do? Oh, what did I do? I got back to seeing you guys. Just a second. Here we go to Francis Casey. I think I can bring it up right here. There, Francis Casey says, flip back there. One. Oh, no, wrong way. That way. There we go.
Whoa.
Whoop, whoop, whoop. Francis Casey says, "Hello, I have attached 2 pictures for your consideration. These were taken on August 22nd at Fundy Park at the Hastings Road parking lot." Cool. I know where that is.
Beautiful.
Nice.
Gorgeous.
Both are single images with cameras mounted on Star Adventurer tracking mounts.
Oh, sweet.
So he has the Lagoon and Trifid Nebula here, Canon T5i 70 to 200 millimeter f2.6 lens at 200 millimeter, 30 seconds ISO 800. Awesome shot. Yeah.
Yeah.
Gorgeous.
He's got here's the Andromeda Galaxy, He's got it as
Sure.
well. M31 or Andromeda Galaxy, Canon T3i, 70 to 200 millimeter f2.8 lens at 200 millimeter, 30 seconds, ISO 1600. Awesome.
Yeah,
Nice job.
Thanks,
fantastic.
Francis Casey. So thank you, Francis.
It's nice to see Andromeda again.
Absolutely.
Yeah.
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 Yeah, we know the time's coming.
Yes.
Got here. We have from Cheryl Stephen. Good morning, she says. This must have been this morning. This is the best I could do with my camera. It was nice to look at through binoculars, though. So there, she's got a shot of Mars and the Moon from this morning.
That's what it looked like when I was sipping my coffee at 2 o'clock in the morning.
There you go. Well, thank you, Cheryl, and that one is your entry into the contest as well. So you've been entered now.
Yeah. You know what that's nice about that photo is she got the color of Mars in it.
Yeah,
Yeah.
that's
I
a
know.
tough one.
Beautiful.
That's hard to get.
Yeah. Yeah.
And it's so like, I mean, the moon is so bright, and when you want to bring the moon down to be able to get a view of the moon, I was finding last night I was losing Mars altogether right out of the shot. So you have to try to find that balance in between. So you can overexpose the moon to get that reddish color. But what a nice little display there. And that, I mean, that display should be there again next month as the moon gets into its waning phase again. But I'll look ahead and see where we're going to be for that. And here's one of Renat Sendis. She says the first picture looks. This picture looks like a too fast incoming UFO turning on final approach. I have to agree with you, Renat.
Very nice.
Yeah, that's still great though.
Oh, it's a great shot.
Yeah,
I like it.
awesome.
Absolutely.
We don't want to talk. We don't talk a lot. We don't talk enough about UFOs on this program, do we?
They're UFP. They're not a UFO anymore. Didn't you explain that?
They're what?
The
Yeah.
UFPs.
Oh, there.
UAP.
We got to talk about that.
Unidentified aerial phenomenon now.
There.
Yeah, you missed it.
I did miss that. I'll have to get back to that. We'll have to make that a program some night.
I thought you
We'll
were
invite
the
all
one
the we'll invite all the moon conspiracy theorists and the flat earthers all onto this, and we'll have a great show.
that.
Oh well. Everybody to their own.
That's right.
Anyway, Paul, we're going to carry on with you now, I guess, with your Rosanna's segment. And you know something, I had to surrender now because I've been having so much trouble with our issue. If Peter's on here tonight, Peter, I apologize, but I've surrendered all of this now to the hands of Paul, who's going to provide the musical entertainment background as well as the presentation. So, take it away, Paul.
Okay, you just give me 1 second. I'm going to do it, get it ready. Or I'm going to try to get it ready. We'll see what happens. See if I trip and fall first. There. I've never done this before, so this should be fun. All right, so I'm going to present. Oops. Entire screen. There. Share.
Oh, it can't get any worse, Paul. You don't have a very high bar here to have to climb over, so.
There you go. Okay. We're going to try. Here we go. Quick. Maybe I open up. Is it not going to work for me?
Rosanna's Fun Fact.
Hey, that worked.
Hey! Rosanna. And this is the first time we tried that, and hey, it worked. So we're doing okay.
Awesome. Yeah, I'm jealous.
Is Rosanna up on the screen?
She is. Do you want me to pin your presentation?
No, that's good. I think it'll probably be okay.
Okay.
Okay, so what Rosanna had sent in this week, she said that she wanted to try to do a segment that's going to go over the course of a couple of weeks because there's just sort of continuances to it. And I thought, well, that'd be great because she's always working on just individual things, but we're going to focus on something here for the next couple of weeks. So she says back, and I'll put the first picture up first. See that okay? So back in 1996, a strange asteroid was spotted in the main asteroid belt between Mars and Jupiter, and it seemed to have a tail like a comet, and it lasted for about 2 months and then just disappeared. This grabbed some attention at the time, but was considered just one, like a one-off freak kind of a thing. In 2002, PhD student Henry Shea was peering through a telescope at Hawaii's Manuka. He was looking for 133P, the freak object with a tail from 1996. So working with his advisor, David Jewett, he hoped to find signs that the tail had returned to 133P. They were in the right place at the right time as they found it immediately and spotted a faint tail trailing behind it. For the rest of the year, they kept track of 133P and its tail until it went behind the sun. When it emerged, it was once again just another rock back to plain old asteroid. Oops. So, although random impacts from debris could briefly create a tail, Shea states that it's very unlikely to have two such impacts occur twice in 6 years to the same asteroid. So suddenly it seemed that there was indeed a comet traveling in the asteroid belt. Traditional comets, balls of ice and dust, come from outskirts of the solar system, and as they get close to the sun and heat transforms the ice directly and to a gas, creating their signature streaming tails. The asteroids in the main belt spend their lives already close to the sun, comparatively. Any water ice on their surfaces boiled away eons ago, leaving only a rock behind. Somehow it would seem that 133P held on to its ice long enough to create a tail. And I'll show you this next image. There we go. So Shea and Jewett predicted that the oddball asteroid would masquerade as a comet again in 2007, but by the time P133 did indeed reappear with a tail in 2007, astronomers had spotted 3 more imposter objects projecting comets' behaviors. So by 2016, nearly 20 tailed objects had been discovered. So many thoughts of this image, the one you're looking at now, which is P2010A2, resembled a Romulan bird of prey from Star Trek.
Sure.
The plume of the gasless dust may have resulted from 2 objects smashing into each other at 9,321 miles an hour. With all the new sightings, Jewett and Shea began to wonder if these comets/asteroids could help answer questions about the origin of water on planet Earth. So there's more to come on this topic. And awesome. Let me get that there. And that was
Rosanna's Fun Fact.
Hey, well done, Paul.
We did it.
Nice job.
Hey.
Okay, we got a new star. I'm stepping aside. I've surrendered the role.
We did it. I can't believe it.
You did a great job.
Yes, sir.
Wasn't quite as funny as mine, though, but oh well.
Yeah. We're going to miss that tripping and falling, aren't we?
We are. Well, that was, yeah.
Oh, we'll find something else. Don't worry about that.
We'll find something else to trip and fall over, yeah. Paul, there's a number of questions in here I guess we didn't get to.
Sure.
Let me see what happened here. At ISO, so Renat's asking, at ISO 100, my Canon only goes to 8.0. What do I use to start out with?
Her camera. Oh, so her aperture is only f8. It must be a really long lens. I'd have to know a little bit more about it. But if she's shooting at f8, that's a pretty small aperture. But that's fine because the moon's really bright. You can shoot at f11, right? So I kind of would need maybe for her to clarify what that.
I'll see if she can return a statement here. She wants to start with the moon. What settings do I use? But I'll see if she'll come on back here again. I think maybe the rest of them.
To me one more time, just to see if I missed something.
Sure. It says at ISO 100, my Canon only goes to 8.0. What do I use to start out with?
Okay, 8.0. I'm not sure what that is. If it's 8.0 for aperture, I don't know. Is there a lens? Is it a DSLR? Is it a removable lens? Is it a zoom kind of a camera where the lens is fixed? Like I don't know enough exactly to answer that question.
We'll wait for maybe a minute or so. Talk amongst yourselves for a minute, and we'll see if she comments back. It usually takes about a minute for the response to go out to Facebook.
Mm-hmm.
That's probably going to be our show for this week anyway, though, right? We're running, we're into Look at that, an hour and 24 minutes. Boy, we can't seem to squeeze it down into an hour anymore.
No, not gonna happen. I think we've given up on that.
I think so too, yeah. Kim says, I can't wait for that. She been shooting the Milky Way, and I got a picture of Andromeda Galaxy as well. So she was talking about Andromeda there, of course. And that now, of course, is up in our evening sky, well placed now in our evening sky.
Yeah.
So nice and high early. And as we get farther into fall, it's going to be even higher. Andromeda is always a really nice target. And beautiful through binoculars too. Like it gives you really the best view through binoculars or a wide field eyepiece to get the whole thing in the shot, right?
Yeah.
Okay, so I haven't seen much of a comment back from her. Not if she does comment here later on Facebook, I'll get
Just,
back to you on the fall.
you just PM me, and then I can
Yeah.
once I know, or she can PM me if she wants to,
Right.
and then I'd be happy to answer the question.
Okay. It's
Then
perfect.
I can have a conversation and kind of make sure I got the right information, so
Right.
I give the right advice.
Marlene says, thank you so much for doing this. You're filling my lifelong obsession with the night sky. Well, it's just getting started. Believe us. Yeah, it's a wonderful hobby. It really is. I've been at it for, I guess, 15 years now. Mike's been at it longer than I. Mike introduced me to it, really. Kurt and Mike and Paul come in shortly afterwards, but we've all been at it for quite a long length of time, and I would really like to do nothing else. Renat did come back saying she's got a 40 times visual zoom. Maybe Renat, I'll give you Paul's PM, and you can talk back and forth to him on.
I'd be happy to help out. Absolutely.
Great.
Yeah.
So yeah, somebody said one of the prizes here, Paul, would be nice to have would be one of your signed prints.
Yeah.
For a contest, we should use one of your signed prints. I put you on the spot.
Okay. I got to find one that's good enough.
I don't think that's an issue.
I'll tell you what. What's that?
There's a beautiful one hanging on my wall right here.
There you go.
Hey, you know
And on
what?
my wall too.
Maybe I can do that. Yeah, I've got the Eastern Tail done on canvas, so
Yeah.
maybe we can do that.
Yeah.
Well, that would be awesome. We may end up
So,
doing that.
but keep in mind, starting probably over the next couple of weeks, Mike and I will be able to start offering live views again.
That's it too.
Hopefully.
So yeah, that's where we're headed now. I mean, we're at I guess we're at what time are we now? A little after 9, I guess. Or we're later
A
now.
little after now, but it's
9:30.
dark.
Yeah, it's
stuff.
dark now. So we're getting
my
very close, folks, to offering these live views. Like we really was the reason why we started the show in the first place. But then we ended up with maritime skies and 90% cloud cover, and we ended up trying to drum up something else to talk about. And I guess we've done pretty good, along the way. We've covered some pile of topics. There's been some
Coming
pile of
up
things.
on a year.
Almost a year. I think next month we're into 1 year of this. Wow.
Wow.
And we've all summer long, of course, we had to wait until the skies get darker, like they are doing now. When we're trying to keep this 8 o'clock time frame because it seems to be good for everybody to come on. Actually, I didn't even put a post up today about our show. I forgot about putting a post up saying that we were going to be live, and here we are with a bunch of people on here. So great. So people are starting to tune in at 8 o'clock on Sunday night, knowing that we're live, which is exactly where we were hoping to be. But we are going to start offering these live feeds, is what we were doing. Paul and I were doing last night with the moon. And what it is basically are these two guys, Mike and Paul, with their home observatories, and they stream into me their live views of objects in the night sky. So we're going to take a look at some deep sky objects like the the Andromeda Galaxy, the Hercules star cluster. Lots of nebula. We'll stay away from Cygnus, but any other nebula out there is always good. We'll have the Orion Nebula. We'll have all kinds of Betelgeuse star. We'll talk about all kinds of topics, and what we try to do is maybe offer 3, possibly 4, no more than that in one night, because we still have other segments we want to get into as well. We don't want to get into a 3 or 4 hour show. Although it's okay for us, but we don't think you guys will put up with it. So I want to keep you guys coming back. But we'll be running into about an hour and a half show, and about half of that show or more will be all live streaming. So we'll have what they do is they capture basically a photo of the object, and then they take another photo 10 or 15 seconds later, and they stack it on top of the last photo. Then they just keep stacking photos until the image gets better and better and better as we're viewing it. So we're seeing something like the Andromeda Galaxy from 2.5 million light years away, and we'll start to be able to see some structure and a lot of detail in objects that you can't necessarily see with your naked eye or through a telescope necessarily, because these cameras are able to stack these photons up very nicely. So and that's going to be all live too. So we'll be offering what you see in the telescope will be a live view. So that's coming up very soon. Within, I would say, by the end of this month, we'll be back at it for sure. It won't be any longer than that for sure. And then we're going to try to keep some of our regular segments as well, of course, to keep you coming back for those as well. But we've got some really interesting times coming up ahead. Now, moving ahead to next week, Paul's already got a talk lined up for next week for the continuation here of the beginner's DSLR astrophotography information. I was asked about the zodiacal light last week on an email. And I apologize that we didn't get to that topic this week, but I did promise that we try to bring that up. I'll put up a little presentation on that next week to talk about the zodiacal light, what that means, and when we'll be able to see it. That's coming up very soon as well. So, Mike will round up something for you. Good
I
to
got
see the
my two
guys.
Give me suggestions I want to come up with.
There you go. You're punishing them for making a mess behind you, so that's
Yeah,
good.
they gotta clean up their mess.
Guys, awesome. Another great show. Thanks a bunch. So, guys, in closing tonight, we'd like to thank you all again for your continued support. Remember, we do love getting your photos. And again, you can send them into SundayNightAstronomyShow@gmail.com, and we'll squeeze in as many as we can on the broadcast. Also, please consider entering the current contest that I have going on for a chance to win some great prizes. The contest ends on September the 10th, so all you have to do is go outside, take a shot of the moon, take a shot of the planets, send them in as individual photos. I'm not judging any entries. They are all accepted, and you have an opportunity to win some nice prizes. So you can either send them into my Facebook page on the comments section. You can send them in as a PM on my Facebook page if you like. If you're on Instagram or whatever, joining us from there, you can send them into SundayNightAstronomyShow@gmail.com. That's our address. And I will haul in all those entries, put them all together. I'll display them as an album for people to take a look at first to make sure that you're included, and then we'll do our draw right after that. So that draw will be coming up next weekend. We're also looking for suggestions for topics for future shows, as always. So if you have anything you would like to discuss on a future episode, something that's puzzling you want to ask some questions about, we're happy to dig into that topic and do some research for you. So please send your requests into the same address, SundayNightAstronomyShow@gmail.com, and we'll do our best to make it happen for you. Also ask that if you enjoyed the content here tonight and you joined us from YouTube, please consider giving us a like and a subscribe on the channel. And please let your family and friends know that we're here every Sunday night at the same time to help educate you and mostly entertain you as well on the night sky. For me, I'm going to taking a few days away from social media just to try to recharge a bit and try to spend some personal time with some family. So I apologize if I can't get back to your questions over the next day or two, but I'll be back to you again shortly before the end of the week. But I just need to take some time to learn a little bit more about the night sky on my own. I don't get enough research time, enough time to go back and look at topics that I've been questioning about myself. So, but I will be back with you all again very soon. And of course, next Sunday night we'll be here as well. So for now, then, from Paul and I, and Mike is here this week. Yes, hey Mike. I had my lines from last week. So from Paul and I, Mike. Stay safe, everybody. We wish you all clear skies, and we hope to see you all here again next week. And remember, as we like to say here on the show, keep your scopes pointed up.
Point it up. Yep.
There, our symbol, the sign-off symbol. Thanks, everyone. Thanks for joining on. Take care. Have a great week. Good night.